Hi, this is Irv Shapiro with the MakeWithTech channel, formerly the Dr. Vax channel. And today I'm going to tell you a story, a 3D printer story, in this case about my Artist D Pro printer from ANET. That's about a $580 3D printer that I thought was broke. In trying to fix it, I broke it. How I fixed it, and found it wasn't really broke to start with. Now, this story is applicable to anybody with a 3D printer. You don't have to have this particular model, because I'm going to talk about the things I tested, things I looked for, things you should look for if you think your 3D printer is broken. So stay tuned and let's learn something together. Well, folks, let me begin the story. But before I begin, I want to point out that in the introduction, I just watched it right before I moved my set around, removed the 3D printer, because it's not really as much about the printer as about the process. I noticed that I probably misused the verb broke and broken. So for all of my viewers around the world, broke is the present tense and broken is the past tense. And I might have been a little sloppy in my introduction. So enough about grammar. I'm an engineer. Grammar and spelling are not my strong suits. Here at the MakeWithTech channel, we try to teach people how to use desktop technologies to make things. And by the way, if you want to learn about all of our videos as they're produced, subscribe to the channel, click on the bell below. Often, the tools we use break because they're mechanical electronic tools. They're gonna break. And therefore, we need to be able to fix them because in particular, if you order a 3D printer from overseas, many of them come from China, you can't call the repairman down the corner to come and fix it for you. You have to be able to fix it yourself or buy a new one. Now, in another video later in the month, I'm going to talk about that challenge overall, but here I want to tell you a story about a 3D printer that I thought was broken and that I broke when I was trying to fix it. Then I repaired, and in fact, it was never broken to start with. So let's get started. The Artist D Pro is an IDEX 3D printer. That means it has two extruders. Here's the extruder in the case. Here's an extruder outside of the case. It has two extruders that sit side by side. They can both be moving at the same time, or one can be parked in a storage location and the other one can move. They're on a shared x-axis, so they can move side by side differently, but they have to move up and back and vertically at the same time. Well, I have been using this printer a lot because I've been doing some comparisons between the Artist D Pro line and the Flashforge Creator Pro line. And they're both good IDEX printers for very different marketplaces. The Artist D printer is really more for the enthusiast, somebody who wants to get their hands really dirty and fine-tune it and work with it and will be repairing it on their own and maybe upgrading it on their own. Whereas the Flashforge printer is more of an appliance. I view it like a sewing machine. You need to know how to load the thread. You need to know how to make some adjustments, but pretty much you take a Flashforge printer out of the box and you can print with it. The trade-off is the build area of the Flashforge printer is much smaller than the build area of the Artist D. So you're trading more or less sort of ease of use from some points of view for a larger print area. Enough of that. Here's what happened to my printer. I've been printing a lot. It's been working perfectly. And I was trying different modes. I was trying using it in auto park mode. That's where your slicer really doesn't have to know about the dual extruders other than the ability to tell it to switch to a different extruder, because when one extruder starts moving, the other extruder automatically parks off on the side so they won't collide with each other. I also was trying to use it in mirror mode and duplicate mode, where your printer can print two mirrored copies or two duplicate copies of the same print at the same time. The slicer doesn't have to know anything about that characteristic. It's done in the firmware. So then I went to change the filament in my right extruder. I changed the filament in my left extruder, no problem. I went to load new filament in my right extruder. It heated up properly. Everything looked fine. I clicked on the load option. I'll show you a picture of that here on the screen. It's built right into the firmware. No filament came out. So I assumed the filament was jammed because that's the most likely thing that happens. So I pulled the filament out manually. I heated the extruder up to a little higher temperature because that's generally the procedure I use. I took a short length of filament that I could push through manually. I released the gears. I pressed it down. The filament came out just fine. So that looked good. So then I went back and I tried auto loading filament. No filament came out. Then I went to the menu item for the extruder, and I'll show you a picture of that here. And I went and I tried to manually extrude filament. No filament came out. I tried it on the other extruder. It worked fine. So I assumed at that point there was either something wrong with the gearing or the motor or something. So these extruders on this printer are in this little metal box that's attached to the x-axis. There are two screws here, there are two screws here. It's pretty easy to take them out. And the ANET printers are pretty unique. There may be other printers that do this, I'm sure there are, but for my purposes it's relatively unique because the cabling is all on these ribbon cables. So I was able to take the extruder out, plug the ribbon cable back in, heat it up to temperature sitting on my desk, and went to extrude, and I could carefully watch the stepper motor now. It was easy to see. In fact, I realized I probably could have seen it through this grill, but I watched it and the stepper motor wasn't turning. So what do you do next? Well, in general, working electromechanical devices don't just fail. They may go out of adjustment. They may get noisier. There may be other issues, but they don't just fail unless something simple has happened. What's the simplest thing that you need to check every time? Check every single cable. So on the ANET, you'll see in this picture here, there's a cable from the base of the printer up to a little adapter board that splits out some of the cables, and there's another cable that plugs into the extruder. I checked all those cables, I turned it back on, I tried again, zip, nothing worked. So at that point, the next thing I assumed was, well, probably I have a bad stepper motor. Yeah, I know they don't fail very often, but maybe mine had failed. Or maybe it was the electronics on this side of the printer. Now I know they share a control board, but you have this little breakout adapter component. I didn't know if that was active or passive. I now know that's passive. I'll show you a picture of that here. So I tried something based on the assumption that the two sides were really identical. Rule number one. If you have multiple components on your 3D printer, even if they look identical, don't assume they are. You have to absolutely verify it. You have to verify model numbers on stepper motors, on components. You have to verify cables. I just assumed the two extruders were the same. So I took the ribbon cable from the left side, I plugged it into the right side, I powered on my printer, and poof, a little blue smoke. I turned it off right away. one of the ribbon cables had started to heat up and actually had melted a bit of the insulation. Now, these ribbon cables are interesting. They're flexible, they're easy, but the individual wires in them, they're called traces, are really very thin. They can't hold a lot of current. So if something isn't right, you're going to end up with a problem. Well, at that point, I thought I had just fried my whole printer. But I disconnected it, I connected it back to the working extruder, everything still worked. What I've learned since then is many of the wires in here do not actually get used. They only use some of the wires in here, and so maybe I damaged a wire that wasn't being used. But my right extruder still wasn't working. So now my printer was probably under warranty still, but you know, I'm a lucky guy. YouTube pays me a little bit of money for making these videos, so I thought instead of waiting to go through the whole dance of emailing the manufacturer, waiting for them to get back to me, finding out what they wanted me to test, having a replacement part sent, I would just order a new extruder assembly. Okay? Not optimal economically, but it was only like 50 bucks, and so it wasn't a terrible thing. And I really wanted to get this up and working because I was working on videos. So I ordered the new extruder assembly. I got it. I plugged it in. Poof, a little puff of blue smoke. What's going on here? Now I knew they were different, so I ordered one for the right-hand side. But you'll notice there's a little adapter board on top here. When I looked more carefully, this is version 1.1. On the old one, it was version 1.2. The adapter boards were different. I had ordered a new assembly for the Artist D. I was using an Artist D Pro. They had made a change in how they use the wires. Now, fortunately, ANET ships you extra cables with your printer. I guess these sometimes can get damaged. And I went online, I ordered some more. But at that point, once again, I thought I'd broken everything. I tested everything was still working. What it ends up is that because these wires are so thin, they're acting like fuses. When I connected it in the wrong way, I just fried a cable. I didn't fry another component. So I went into the Facebook group for ANET, and I also sent a support request to support at ANET. Interestingly enough, they got back to me, ANET, within 24 hours. The support group was very helpful. They said that the extruder assemblies, they're pretty sure, are identical between the Pro and the basic model, except for the board was different because they had changed how they route power to the heater element to use more of those individual thin wires, so it would be more efficient. So I took the version 1.2 board off of my old extruder, thinking the stepper motor was broken. I put it on the new extruder. I grabbed some extra cables out of the box. I hooked everything up. I turned it on. No blue smoke. It worked properly. I turned the heating element on. I heated up the extruder. Came right up to temperature. No error messages. I clicked load. Nothing happened. So what's going on here? So there are more cables. There are cables inside the actual base of this printer, which is where the electronics are. This printer uses standard components. It uses an MKS Robin Pro controller board, a Maxwell power supply. So I thought I'd take the bottom off the printer and take a look and make sure nothing was loose. I go to take all the screws around the outside off the bottom of the printer, go to get the bottom off. Can't get the bottom off. It's stuck. So I take some more screws off, thinking maybe I missed them. Maybe these screws that don't look like they hold the bottom, hold the bottom. I went back to the user group, and somebody mentioned that there are two foam supports inside the printer that are glued to the bottom of the case and the bottom of the printer. And so you have to heat those areas up with a heat gun. I'll show you those in these pictures. It's those two foam supports you see in this picture. That's where the bolts for the gantry go through. They're used to guide the gantry, but my guess is they also attach them so the bottom doesn't rattle at all to probably make it produce less noise. So I heated that up with a hot gun. I took the bottom off. Here you can see once again a picture of what this printer looks like. I thought it was very well done inside. Things were done cleanly. Cables were properly tied down. I checked all the connectors. I found one of the stepper controller chips was a little loose. At that point, I didn't yet know exactly what the layout of the board was. Since then, and I'll show you this on the screen, I found a layout for that board online. So I reset all of the stepper controller chips. I made sure the cables were set. All the cables on this printer have a little bit of hot glue holding them in. So I didn't take the hot glue off. I just made sure they were all firmly in place. I flipped the printer back over. I put the gantry back on because I disassembled that, thinking that was interfering with getting the bottom off. Connected everything back up, turned it on, no blue smoke, heated up the extruder, went to extrude some filament, and nada. But I noticed something this time. Before I extruded the filament, I raised the x-axis up higher so I could more easily see the filament coming out. And I noticed that when I went to extrude filament for the right side extruder, the number 2 extruder that wasn't working, filament was coming out the left side extruder. Now, why didn't this happen before? Well, there were 2 reasons. Number 1, this time when I reassembled it, I tried the working extruder first, so I brought it up to temperature. So that extruder, that second extruder, was still hot. I then tried to extrude from the right side extruder, and since that extruder was still hot, something was causing it to extrude from the wrong extruder. So then I had an aha experience. A light bulb went on. The last print I had made on this printer had been in duplicate mode, where the printer in firmware moves both print heads simultaneously. So you can make 2 copies of a print. I was making some roses for one of my granddaughters. And while the heating elements seem to still be controllable independently, when in duplicate mode, it seems that when you go to the front panel and you do anything with loading filament or extruding filament, it always goes to the left-hand side. Now, you could see how a programmer might think that's reasonable. I think it's a bug, but in fact, my printer was never broken. So what are the lessons we can learn from this? Number 1, when something doesn't work, go back to a known good state. Take and start over with something you knew worked before. Now, in my particular case, the fact that I couldn't load the filament seemed to be uncorrelated, but never assume they're uncorrelated. Go back and basically reset your printer to the beginning settings and start over again. Because you have to worry about firmware and cabling and components and electronics. You want everything to start at the same place. Number 2, I still believe that for the majority of users, the majority of your problems will come because of loose cables. These things are bouncing around all over the place. Cables come loose. So check your cables next. Number 3, don't assume that 2 components, maybe 2 stepper motors, maybe 2 stepper motor drivers, in this case, 2 extruder assemblies with the little adapter boards, are the same just because at first glance they seem the same. If you can't find a specific version number that indicates right or left, then go to the online user groups, contact the manufacturer before you cross-connect any components. Because maybe if I hadn't had ribbon cables that burn up easily, I would have damaged my printer in a much more significant way. Number 3, leverage online user groups and email the manufacturers. In this case, ANET got back to me in 24 hours. Now, this is the only experience I've had with them in terms of support, so I can't tell you they're always going to get back to you in 24 hours, but they got back to me very quickly. So take advantage of those resources. And finally, if you're going to be using a home grade 3D printer that sells for under, let's say, $1,000, you should probably assume you're going to have to learn how to fix it when it breaks. So watch lots of videos, slowly start looking at how things are assembled. The more you learn about your printer, the happier you will be with your experience. Folks, I hope you learned something today. I learned a lot from this experience. And if you did, please subscribe to the channel, give me a thumbs up, share this video with everyone you know. I do feel that the ANET Artist D Pro is a solid printer. I know people have had difficulty with the extruder. I haven't. I thought I was, but in fact I wasn't. I can also tell you, though, that I believe ANET, based on some correspondence I've had with them since I made this repair, are working on potential upgrades to that system. So you may want to keep track of what's happening with the Artist D and the Artist D Pro, which are printers I still believe deliver good value. Thanks so much, and let's continue to learn things together.